Problem number 1 is solved by graphing. This was all over your IXL yesterday, if you remember doing it. The first problem is actually very simple. It's very straightforward, where in case, and I'm not going to, well, never mind. They're both solved for y, so graphing it's not going to be the end of the world. Like Endgame was, almost. If I want to graph this in green, I put a dot where the 4 is. The slope is -3. In other words, the slope is -3/1. So remember, negative slopes go up and to the left or down and to the right, and the slope represents rise over run. So I can't go up 3, left 1, because I don't have the space, but I can go down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Okay. I take my ruler, just like Thanos tried to be the ruler of the universe, and I'm going to draw a straight line through those dots. Bada bing. Now, if I'm trying to solve a system of equations by graphing, I am just drawing 2 lines and finding out where they intersect, and wherever they intersect is going to be my answer. Okay, so the second guy is at -2. Which means I put a dot at -2. It's up to you guys if you decide to take notes. It's really hard to take notes because, you don't have the graphs unless you bought graph paper. But like I said, this is on video, so if you're good watching this, then notes aren't mandatory. But it's good physical practice. Like, studies show that if you take notes, you're more likely to succeed. When we're in person, you're going to take notes, but we're not in person right now. The slope is 3/1, which means up 3, right 1. So up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Uh-oh, ran out of room. So I'm going to go back to my original dot, and instead of going up 3, right 1, I can go down 3, left 1, because that goes in the same line direction. I'm going to take my ruler, and I am going to draw a line through the purple dots. And again, my solution to a system of equations is where the lines intersect. Okay, and since I'm graphing, it's obvious. I bumped the camera. It's obvious where the lines intersect, and it intersects at what point?
One.
Very good. So I'm going to write down that point. Now, this isn't going to affect you that much when you take the online test, because the whole online test is multiple choice. But if we were in person, just graphing is not good enough. You have to actually tell me what the point is. Okay? When we say solve, and we're going to do 3 more solve problems on this page, make sure that you give me a point, or at least say x is 1, y is 1. And if I wanted to do a quick check, what I would do is I would take the fact that x is 1 and y is 1, and I would plug this into the top. So I would say 1 equals -3 times 1, which is -3 plus 4, and I get 1, and I'm just checking my work now. But, I don't need to do that here because time is money, and I have very little of each. Except for money. I have tons of that. Tons of money. Thank you, YouTube. My cousin's rap career also helps, too. He gives me money for writing credits. All right. This not so easy. Because y is not all by itself in either case. So what I'm going to do is up here, I'm going to put this one in red. I'm going to rewrite x minus 1 equals 3, and I have to solve for y. Be very, very, very careful of that little negative that's just kind of lingering around that doesn't seem like it's important, but really is. Just be very careful. If I want to get y all by itself, my first step is to subtract x from both sides. Now on the left, I have negative y, not y, negative y equals, on the right, I have a negative x, and I have a positive 3, so I'm going to write it out like that. Now, what negative y means is that I have a negative 1 in front of y. Okay. But what it also means is y is opposite. So if I want to find regular y, there's two things I can do. I can divide everything by -1, and I'm doing my air quotes, or I could just use common sense. If negative y is negative x, then positive y is positive x. And if negative y is +3, then positive y is -3. And if you're like, did you just make everything opposite? Yes, I did. And that's all I did. So I'm now going to graph, that was the top equation. I'm going to graph that in red. My y-intercept is -3. So I'm going to put a dot at -3 way down there. Let me zoom out just a teensy bit. I'm going to quick pin my screen to make sure that's nice and clear, because I can't tell if that's nice and clear. Yup. All right. Unpin. Okay, so I have, now you can see that better. I have -3 as a y-intercept. I have invisible 1/1 as a slope. I think we can all agree with that. So it's the easiest slope ever. Up 1, right 1. 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 Uh-oh, I ran out of room. Down 1, left 1. Down 1, left 1. Uh-oh, I'm done. Then I take my ruler, I take my straight edge, and I draw a perfectly straight line. And there you have it. That's the one. Just not happy with the angle that this camera is at. It's a little bit better. Now, taking a look at the second equation, that's not easily graphable either, because it's not in slope-intercept form either. So I'm going to take this guy, I'm going to rewrite it down here, 7x minus y equals -3. Is y all by itself? No. What is in the way? 7x. What else is in the way? A negative. Always get rid of the guy that's floating around first. Subtracting it from both sides, you get -7x and -7x, and that crosses you out. If I rewrite it out, I have -y equals, and I'm going to write it in a way that's slope-intercept-y. So that's -7x minus 3. And I'm going to use the same wording that I did up there. Yes, I can divide everything by -1, or I could just use common sense. If -y is -7x, then positive y is +7x. And if y is -3, then positive y is +3. And again, what I did is, if I had -x and I want regular, I'm sorry, if I had -y and I want regular y, I'm just flipping the signs on everything, because it's opposite. Okay. Those of you whose screens are not zoomed in, it probably may not be the worst idea to zoom it in if you can't see that well. Just click on my screen and pin. I know it's hard to see graphs when they're far away or on a small screen. So I know, I'm looking at my screen and I can't see what I'm doing on my computer. So good. All right. Put a dot at +3. The slope is 7. Okay, which means the slope is 7/1. So I definitely can't go up 7, right 1, but I can go down 1, 2, 3, 4, 5, 6, 7, left 1. There's my magic dot. I can only make 2 dots. Those are my lines. And those of you who have courage and bravery, where do these 2 lines intersect?
-1, -4.
I agree. And again, the way you check your work is you take that answer right there, knowing that -1 is x and -4 is y, and you plug them into both equations that you can't see at the very top up there, and make sure it's a true statement for both. Okay? As much as I would love to do that, I really can't show you everything because I just don't have enough room. But you guys get the idea. All right. Now to the thing that people hate the most. Systems of equations. Did I accidentally just unplug my thing? I may have. Uh-oh. 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 Frozen? I was frozen for a second there. Oh no, if I'm frozen, then maybe I should just let it go. You probably don't get it. Now look at those equations. By golly, Mr. Parrott, you say, those are the same. And they are the same. You're thinking, Mr. Parrott, what are those? Those are the same. What are those? Well, they're the same exact thing. But in one case, and I'm trying to weasel my camera in a way that you can kind of see both at the same time, they're the same thing, which means I know I'm going to get the same answer. But I'm going to do different processes. Processes? No. I'm going to do different processes to get that same answer. So the whole purpose is to practice substitution and to practice elimination. So, substitution. Substitution says I have to take one of my equations and I have to solve it for either x or y. So, the easiest thing to do if we're doing substitution is to probably solve the bottom equation for x. And if you're wondering why, it's because x is already by itself and the only thing in the way is negative y. So if I'm going to rewrite the bottom equation, that's all I'm doing. If I want to get x all by itself, unmute yourself or put it in the chat. What's the one step I have to do?
I think you're supposed to subtract the x.
No, I want to get x all by itself. You're trying to get y all by itself. Your heart's there, but you're doing the wrong thing.
Then add y.
Add y is correct. So if I want to get x all by itself, then I want to add y to both sides. X equals y plus 13. If you put 13 plus y, who cares? I just try to keep it where my variable's first. It reminds me of slope-intercept form, and slope-intercept form is beautiful. Like every one of you. So I have x all by itself. That was the bottom equation. My next step is to take that bottom equation and plug it into the top equation. Okay, so Lily, who accidentally fell out of the world just now, I solved x for the bottom equation, and now I have to plug it into the top equation. So I'm going to rewrite the entire top equation, but once I get to x, which is now, I'm going to replace x with y plus 13 because x is y plus 13. So instead of saying 4x plus 2y, I'm going to put 4y plus 13 plus 2y equals 10. What property should I do now?
Distributive.
Yay, all of my friends saying it at the same time. 4y plus 52, thank you, plus 2y equals 10. I can combine my y's. It would be y's if you did that. I'm going to combine my y's and get 6y plus 52 equals 10. I'm going to keep using that paper. If you guys can still see it, I'm going to keep using the paper. I have minus 52, 6y equals negative 42. Thank goodness it's not going to be terrible. What would I do to both sides? I'm just not going to show that step. What would I do to both sides?
Divide by 6.
Divide by
Good.
6.
Good, good, good. And y is going to equal what?
-7.
Good. So I have y equals -7. As you remember from the top two problems, my answer is not just x or not just y. I have to find x and y. I have y. How do I find x? Easy peasy. Didn't I say that x equals y plus 13 right there? I said right there, and you can barely see it, that x equals y plus 13. If I need x, why don't I take that y equals -7? Now, you may have heard in the past that you could plug it into one of the original equations, but this is an original equation. I just rewrote it. So I'm going to take that equation right there. I'm going to take the fact that y is -7, and I'm going to say x equals y. No, y is -7 plus 13, which gives me x equals
6.
Good. And so my final answer is going to be the point 6 -7. Now, if you know both processes very, 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 very well, and maybe you do and maybe you don't, I would argue that elimination is actually the better of the two in this case. And here's why. Elimination has you lining everything up, which it already is, and it has you figuring out two variables that have the same coefficient. There's a fly on my paper. It gives you two variables that has the same coefficient but opposite. Okay. Now, I don't have that right now. I have a 4x and an x. They're not the same. I have a 2y and a -y. However, if I took the entire bottom equation and multiply it by 2, what will that give me so that magical things will happen? What's the magical thing that I get if I multiply the bottom row by 2?
Do you want like the whole equation or just the magical part?
The magical part.
-2y.
Perfect. Because my top equation was 4x plus 2y equals 10. Who cares? The bottom equation now becomes 2x minus 2y equals 26. And the magical thing being -2y allows me to take these two equations, combine them through addition, and by combining them through addition, 4x's and 2x's make 6x's, but you go away. Magic! Woo! And it's almost Halloween, so I'm all about that magic crap. So I have equals 36 because I add those two as well. Divide by 6, and x equals 6. Well, no duh, x equals 6. That's what I got over here. See me tapping on the bottom? That's what I got here. So I knew x would equal 6. But again, I would argue that elimination is going to use less time and less space and maybe easier. If you are a purist of substitution and you're like, no, sir, you're wrong. You're a jerk. And I'd rather do substitution and you're a jerk, then that's fine. Maybe I am a jerk. Maybe you're the jerk. Who knows? Am I done? This is where you all at the same time say, no!
I don't want to
do. Which one must I plug that 6 into, the top or the bottom? Trick question.
The top, I think?
Sure. Or...
Wait, no, the bottom. The bottom.
Yeah,
It doesn't matter.
It really doesn't matter. Some might argue that the bottom might be easier because it's x minus y equals 13. So if I just say, if I do the bottom and say 6 minus y equals 13, you know, it might be easier. If you plugged it into the top, who cares? You're going to get the right answer anyway. So I'm going to subtract 6 from both sides. And there's that negative y rearing its ugly head again. So if negative y equals positive 7, then try that again. If negative y equals positive 7, then
Positive y equals negative 7.
hey, I love teaching this class. It's just so nice hearing correct answers and high-level thinking. So there you have it. Oh, you can't see it, can you? You can barely see it. So I have 6, negative 7 right next to that 6, negative 7 that I got last time. And as you know, and you know already, that if I ask you to solve algebraically, if that's the wording that I use, solve this algebraically, solve that algebraically, you could use either method and you'll get the right answer no matter what. It's just with a problem like this, the last thing that we want to do, whether it's this one or whatever, the last thing we'd want to do is graph, because I don't have a graph on this paper and none of them are solved for y. So graphing's not going to be that fun. Speaking of graphing, look what I have. Oh, but these aren't equate. Oh, hold on, you can't see. Zoom. Zoop. 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 These document cameras are great. But it's weird. Whenever I move them, they make weird sound effects and they go zoop. So strange. Technology is the weirdest thing. Speaking of weird, these aren't equations. These are inequalities. I wonder if doing them's any different. Just a little bit. Let me take this one and graph it in purple. Oh, look, it's already in slope-intercept form, kind of. Except this isn't an equal sign. It's something else. I don't know. I'm going to start at -2 and put a dot there. You with me? Good. My slope is -1/1. So I'm just going to quick write that there. Which means I go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Oh, poo. I ran out of space. Down 1, right 1, down 1, right 1, down 1, right 1. That's a less than or equal to. And since it's or equal to, I'm going to include the line. And the way I demonstrate including the line is I draw a nice solid line like that. I guess I'm done. Right, guys? I guess I'm done. Right, guys?
You're not done.
No, I have to shade. Am I going to shade below or above this line?
I don't remember.
I'm glad you unmuted yourself. Below, good. It's below because less than implies underneath, below. So I'm going to draw these pretty little lines right there, indicating that it's below the line. Good job, friends. I'm going to graph this John in red. I'm going to graph that John in red. I'm going to put a dot at 2. The slope is -5 or -5/1. I'm going to go up 1, 2, 3, 4. Uh-oh. I'm going to go down 1, 2, 3, 4, 5. And I'm going to go right 1. Ooh, there's my sweet spot right there. And that's the only 2 dots that I can make. That's okay. 2 dots make a line. That's all I need. I'm going to take my magical straight edge. And since this is greater than or equal to, I'm going to draw a solid line like so. I'm going to shade above the line. Now, above the line looks weird because this is such a steep slope, but the way you visualize what above the line means is if this was a cliff or the side of a mountain and you were climbing up it, you would be climbing up this side over here. So I'm going to shade above the line. And where my purple and my red meet is going to be my final answer. So my purple and my red meet in that little tiny chunk right there. That little tiny chunk right there. I'm going to put an R there for region, because some books call this the feasible region. What's a troom girl? Oh, apparently we offended Elena. She left. Let's do another one, shall we? We're going to do this one kind of fast. So if you're trying to take notes and keeping up, it's fast. Okay, we're doing this fast. I only have 8 minutes with you, and I have 2 problems below, so I want to make sure we get through all of them. All right. Graphing this one, let's choose a different color. Green. I'm graphing that one right here in green. Start at -2 on the y-intercept. My slope is -1/1. So I'm going to go up 1, left 1. This is the same. They're the same thing. They're not the same thing. Okay, they're the same lines. I see what happened. I didn't even notice that when I got these problems, when I stole them from the internet. They're the same exact lines, but the signs attached to them are different. What you have to be very, 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 very careful of is this is a greater than symbol. It's not a greater than or equal to symbol. So when I draw my line, I'm not drawing a solid line at all. I'm drawing a dashed line. So make sure that when you have an inequality sign that's not equal to, you make a dashed line, and that indicates that since it's not equal to, the line itself doesn't count. That's like if you were graphing something like this, you would put a dot at 3, but not fill in the dot. Similarly, we don't have any dots except for these guys, but by putting a dashed line, we're saying let's not include the line. It's greater than. So I shade above the line, which is going to be this side. Now, without wasting a whole lot of time, we already know how to graph the bottom equation. So let me do that in purple. I'm going to start at +2. I can't go up 5, left 1, but I can go down 1, 2, 3, 4, 5, right 1. There's my magic spot. I'm going to take my ruler, my straight edge, and I'm going to make sure again that I'm doing a dashed line because this symbol had no or equal to attached to it. This is less than, so I'm shading below the line. So similarly over here, when we pretended if we were hiking a mountain, we would hike the top part. Well, if we're inside the mountain, we're in the bottom part, and the bottom part would appear here. So the areas where the green meets the purple is in this spot right here. So this is going to be our feasible region. This area right here that I'm making in blue. So much writing. So much writing. I'll put a little R there. Hey, why do pirates like this problem? R. Get it? Stuart Middle High, well done. Shaking my head. Find the missing side. We have 5 minutes, so we might get through one of them, and that's okay. I don't think we need to spend all the time in the world on Pythagorean Theorem. This is Pythagorean Theorem. A squared plus b squared equals c squared. X has to be c because it's the hypotenuse. You're A, you're B. Doesn't matter as long as x is c. I have 7 squared plus 6 squared equals c squared. I have 49 plus 36, and that equals c squared. I have 85, and that equals c squared. I'm going to square root. 85 is not a perfect square. So since 85 is not a perfect square, and I'm a mean teacher, I'm going to say, let's make ourselves a factor tree and actually simplify that radical the way that God intended it to. So 85 is 5 and 17, which tells me that I can't simplify it. I can't go any further. So 85 is done. So my answer is C equals the square root of 85. So you're going to look at that and you're like, that's not right. There's got to be something I can do. I mean, I know I can plug it into my calculator. Yeah, sure. Anybody can plug it into their calculator. Anybody can ask Siri what the square root of 85 is and get 9 point blah, 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 blah. But if I want you to do this, which I will ask you to do on the test, maybe at least once or twice, we need to be good at this. Now, with 3 minutes to go, we should be able to finish this last problem. All right, so let's quick finish that last problem. You're my C. You could be A and you can be B. I have A squared plus B squared equals C squared. So according to what I wrote there, I have 3 squared plus B squared equals 4 squared. You are 9. B squared is B squared and you are 16. Minus 9. Minus 9, cross u out, b squared equals 7. Square root it, and b equals the square root of 7. I'm not even going to bother making a factor tree because I know there's nothing I can do about that.